Hi, welcome dear students. Today in this section, I'm going to solve problems from this section, velocity and displacement with a constant acceleration. So in your textbook, it is on page number 51. It's a practice D. So first I'll solve question number 1. A car with an initial speed 6.5 meter per second accelerates at a uniform rate of 0.92 meter per second square for 3.6 seconds. Find the final speed and the displacement of the car during this time. So you can see the question they are asking the final speed. So you're looking for VF. So the value you need to find out, VF you need to find out, okay, the question mark. Then also they're asking final speed and displacement. So also you want to find out delta X. So these are the two things that you need to find out, VF and delta X. And now let me check what are the values given, okay? A car with an initial speed 6.5 meter per second. So the initial velocity is given, okay? VI. VI is equal to 6.5 meter per second. Then what else is given? Accelerates at a uniform rate of 0.92 meter per second square. So acceleration is given, that is 0.92 meter per second square. Then for 3.6 seconds, so the time duration delta t is equal to 3.6 seconds. Okay, find the final speed. So you are looking for VF. So you may look at the equation. See, VF is given, VA is given, A is given. Sorry, VF you had to find out. VA is given, A is given, delta t is given. You are looking for VF. So now you look at the equation, okay, on the right side. Which equation you can use? See the second equation here, this one, second equation. VF is equal to VI plus A delta T. That equation you can use. So the equation I'm going to use here is VF is equal to VI plus A delta T. So this is a direct question. You just want to plug in the values. So that is equal to VI is 6.5 meter per second plus acceleration is 0.92 meter per second square times delta t is 3.6 seconds. Okay, and this will be equal to 6.5 plus meter per second plus 0.92 times 3.6. So this is going to be 9.812. Okay, 9.812. But you can see the least number of significant figure here is 2. So I'm going to round this to 9.8. So your velocity final is 9.8 meter per second. So this is your VF. Okay, this is the answer for the first part. Now they're asking find the displacement. So if you're going to calculate the displacement, you are looking for delta X. So look at the equation for delta X. You can see the first equation. Delta X is half into VA plus VF into delta T. This equation you can use. Okay. So that's the second part. You have delta X is equal to half into VI plus VF into delta T. Okay. So this is your equation. So now just you can plug in the values. So delta X is equal to delta X displacement, that is half into VI is how much? VI is 6.5 meter per second plus VF. Just now we calculated the value of VF, which is 9.8. The value of VF is 9.8. So that I'm going to use. The value just now I find out 9.8. Okay, meter per second times delta T value is how much? Delta T is 3.6. Okay, so 6.5 plus 9.8, that is equal to 16.3 divided by 2, that is, okay, times 3.6. So your final answer is going to be 29.34. So delta x is 29.34, but you can see here the significant figures. There are only two significant figures. So you can round that 29.34 to 29 meters. So delta x, the final answer is delta x is equal to 29 meters. Okay.